Let's start our tour of concurrency management bugs by considering a single CPU system with a shared resource. If you have a CPU that switches among its tasks, so it's multi-threaded or multitasking, ask the question, what happens if the task switching happens at the wrong time? The result can be concurrency bugs due to shared resources. Let's look at an example. Here we have a timeline, time going from top to bottom. We have two tasks, task 1 and task 2, and there's a shared global variable that currently has the value 5. Let's assume that task 1 reads that value, and then it gets a read, and it decides to add 1. So now task 1 thinks the value is 6, but the global variable is still 5 because it hasn't written it back yet. Now here's the problem. What if there's a task switch after the time task 1 reads the global, but before it has a chance to write it back? Task 2 then takes over, and it reads the global, which is still 5, and it wants to add 3 or do some other computation. Task 2 will complete its computation, it'll add 3, it'll write back the result of 8, and the global variable will be 8. As far as task 2 knows, the value is 8, and it's done its job. But eventually, the task is going to switch back over to task 1, and it still has the 5 plus 1, and so it writes back its value 6. If these two tasks run at different times, the global variable would be 5 plus 1 plus 3. It should give you 9. But what happens here is because task 2 got overwritten by the interrupted task 1, the value is 6. So you get an incorrect value on the global variable, but it only happens when this particular interleaving occurs when task 1 and task 2 are trying to access the global at the same time. That means that the results of the concurrency bug depend upon the ordering.